All right, let's finish off talking about these aromatics. Okay. Um, Last video we learned that benzene is a resonance structure. It's a combination of this molecule and this molecule. It's not one and then the other flipping back and forth. It's both at the same time. We draw this benzene like this. We put a little circle in the middle because if we didn't put a circle in the middle, somebody might look at this picture and say, oh, it's cyclohexane. But benzene is not cyclohexane. So we put a little circle in the middle so that everybody knows that it's benzene and that it's both of these at the same time. What is the hybridization of each carbon? Each carbon here is attached to one two, three things. Anytime I've got three things, I want sp2 hybridization. So let's look at the orbital diagrams of what's happening here. I'm starting off with carbon like this. Right now this thing is ready to make two bonds, one here and one here. It's going to make four bonds in the end. 1, 2, 3, 4. So the first step has to be to promote a carbon up. There it is here. And then we need the right kind of orbital. So we're going to hybridize. I'm going to get sp2. I get a p left over. So I'm going to draw a fairly complicated diagram here of what's actually happening. I've already drawn the carbons and the hydrogens in place just to make it a little quicker. So let's start with this little p orbital left here. Every carbon's got it. Every carbon has a p orbital, and it's going to be sticking up and down out of the plane of the molecule. Yes. And there is going to be sharing around all of these p orbitals above the plane of the molecule and below the plane of the molecule. Yes. So I've drawn this guy. Check. I have to draw these. They're sp2 orbitals. I'm going to change my color. There's three of them. Every carbon's got three of them. One will bond to a carbon on that side, one will bond to a carbon on that side, one will bond to that guy. So I got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, and 3. So, and then I've got the hydrogens. The hydrogens have their one electron in an s orbital. I wish I'd drawn those H's a little further away, but oh well. There's my H's. So, every carbon has a p orbital. It's got three sp2s. 1, 2, 3. One of these is bonding to an H. One bonds to a carbon on one side. One bonds to a carbon on the other side. All of these p orbitals that I've drawn in red have an electron in them, so there are 6 electrons being shared equally between all these carbons. That's what's happening in this molecule. And any sort of, like I said in the last video, any sort of addition reaction coming in here and using one of these 6 electrons to bond would completely mess up this wonderful sharing, this wonderfully stable molecule. And since each bond is not single and then a double, it's more like they're 1.5, which is halfway between a single bond and a double bond. That's why these things are so stable. Okay? Naming. We name these things using the name benzene for the most part. So here I've got a bromo group. I've got a methyl group. I'm going to put them in alphabetical order. I'm going to give bromo number 1. So this is 1 bromo, 2 methyl benzene. There is another naming system depending on where you're sticking two things, but we are not going to use it because it's not part of the IUPAC naming rules. If you've got a group, a benzene group, sticking off a longer chain, so here's a long chain of 9 carbons, 9 carbons, and this is a 6 carbon chain, so this guy's longer. This is called a phenyl branch. So this is 1, 2, 3, 4, 5. This is 5 phenyl nonane. Okay. So if the benzene group is a branch, it's called phenyl. And there are some popular ones. Naphthalene, which is mothballs, which is 2 of them stuck together with these carbons playing a role in both rings and the sharing in both. If I have a methyl group sticking off a benzene ring, they call this toluene. It's a solvent. It's used in many things. If I have a C double bond C sticking off the top, it's styrene, as in polystyrene, as in styrofoam. If I have an OH sticking off, they call this phenol. If I have this C double bond O bond OH group, which kind of signifies it being a carboxylic acid, which is a class of organic compounds, call this benzoic acid. You might have heard this benzoic acid on commercials for different drugs. Often you might hear it in different commercials. This guy happens to be my favorite. Now, if I pretend that these 3 groups are not here, I have toluene, this guy, right? So this molecule is toluene, and then I stick on 3 nitro groups, here, here, and here. So this is trinitro, toluene, trinitro, toluene, also known as TNT. This is dynamite, explosive, trinitrotoluene. So these are just some popular aromatics. And that ends our look at aromatics.